Okay, this lesson is on navigation systems, technically, not just navigation. There's a whole nother lesson on actual cross-country flight planning involving a lot of navigation, of course. But this one's on navigation systems. So make sure you've got your packet, so that you can fill out your notes and whatnot. So make sure you have that handy, and we're going to go through these notes right now. So let's get to it. So in this one, you're going to be learning about different kinds of navigation systems, VOR navigation, dead reckoning, pilotage. Also GPS will be in there. So these will be the things that we're learning about. We're also going to be learning about diversions. And this video, there's a lot of in-class stuff that you do with this lesson. So this is mostly just for the notes. It's really not a lesson on how these things actually work in depth, because all of that stuff will be in the classroom stuff. So first of all, we're going to start with what is a VOR. This is kind of what one type looks like here. And VOR, though, is a ground-based radio navigation system. Also, it provides an azimuth information. Azimuth is just like a bearing in relation to a compass, and for pilots. And it receives signals from a VOR station to determine its position. And it's used for en route navigation and instrument approaches. So essentially what it does is it basically is like this thing that's up there, and it's got these radials coming off of it, and your airplane comes along and it knows kind of what radial it is based on some different gauges and things like that in your airplane. So we're going to talk more about the gauges and stuff here in just a moment. But essentially, yeah, you just basically dial in a VOR on a frequency, and then you dial in what radial you want, and you fly to or from the station based on the radial. It can also be used for, if you're lost, it can be used for some other information as well. Okay. Sorry, I just had to fix one thing there. We watched this video in class. I'm going to try to put this video in Canvas in the modules so that you know to watch that video. It does actually a really good job explaining a lot of the concepts in this lesson in one single video. So make sure you check that out in modules from Pilot Institute, I think it's called. Put that in my notes here. Okay. But there's two kinds of gauges, so label your notes with these. There's the VOR gauge, the traditional gauge. It's a lot of times called the CDI. And then over here we have the HSI, the horizontal situational indicator. And of course we'll explain those in way more detail in class. But I did put a picture in your notes of kind of the different parts of it that are labeled. This is the CDI, the needle here. This is your Omni bearing selector, so you turn this and it turns this thing around. You have a from flag or a to flag. Sometimes it's just a triangle. And then you have a deflection of 2 degrees per dot, 2 degrees per dot on that. The HSI has a lot more stuff going on, but essentially it still has a CDI or course selection pointer. It also has a to from flag. It's this kind of triangle here in the middle of the gauge. This yellow part is the CDI, that's your gauge there. And then this is your scale, how many degrees you're off. And then this is your course deviation indicator over there. Now, the difference here is that they've actually taken a kind of CDI type gauge and laid it over the top of a heading indicator. So that way you always kind of know which direction the course is and things like that. So definitely a way, I think, a little more sophisticated way to do it. I found when I switched from traditional VOR gauges to this, it was way easier. Although I did master the VOR pretty quickly, but some people don't. Some people need to see that course, and I can tell you my situational awareness was way higher using this kind of gauge here than the traditional one. Also, if you're flying like a G1000 kind of aircraft, it uses an HSI type as well. It's just a digital display instead. So if you learn to use that HSI, you'll be able to use that G1000 as well. So we do some practice problems in class, so we'll skip those for now. But essentially how it works is I give you a set of gauges like this, so you're flying a heading of 120 and you have 115 or 120 selected on your Omni selector there, and you're going to the station. So my question would be, well, where are you in relation to the station? Are you to the left of it, right of it, north of it, south of it, or whatever? and then we'll give an answer in class for that. But just so you know, in this case, you're kind of up here in this quadrant right up here, and that's because you've got 120 to the station, and the only way to, you'll have to be on this half of the VOR on that half there you'll need to be on this side, because if you were at 120 selected and it said from, you'd have to be on the other side of the VOR, because when you go over the VOR, it flips from to to from, and you're in that hemisphere. So you have to understand that you cannot dial in a 120 degree radial from that other side. So we do a bunch of those in class as well. Then we go into some VOR kind of parts on a sectional chart. This is a pretty basic VOR that I found on a sectional chart. And it's this kind of blue line with lines radiating inward. Now, a lot of you in the past have called this Class D airspace or restricted airspace, all kinds of things, and I've corrected you many times saying, no, that's a VOR, and we'll get to that in a later lesson. Well, here's that lesson right here. So first thing is the name of the VOR. VORs can have lots of different names. So you can have one word names. You can have all kinds of different ones there. So just so you know, there's all kinds of different names. Sometimes it's based on a nearby airport. Sometimes it's based on a landmark. Sometimes it's just a name. So yeah, we have all kinds of different VOR names. Like at the Salt Lake Airport, we have the Wasatch VOR. Up in Ogden, we have the Ogden VOR, which makes sense, and things like that. So definitely just get used to reading the name there. And then we have the VOR identifiers, 3 letters. In this case, it's Alpha Charlie Hotel, it's ACH. And that's just how you can you can use that. You can actually type that into a GPS as a waypoint. You could also use that in a flight plan filing. You could just type in ACH Alpha Charlie Hotel, and you'd get that. And then we have the Morse code there, identifier, and that you don't need to memorize Morse code. It's right here on your chart, but you do need to use that Morse code. So what you're going to do is you're going to dial in that VOR into a radio type box, and then you can actually listen to that through the speaker in the plane or your headset, and you can hear that Morse code. And you shouldn't use the VOR if you don't hear that Morse code. It could mean that the VOR is out of service. It could mean you're out of range of the VOR, or it could mean that you have the wrong frequency dialed in. So definitely check your frequency if you're not hearing that that Morse code identifier. But you can read it right off the map and just listen to what you're hearing and make sure that that they match up. These numbers that you see around the compass rose here, those are just radial numbers. So you don't have to fly those radials. You can fly any radial you want, but those are just there for your reference. Notice how this 0 line kind of goes off to the right here. It doesn't line up with the line of longitude here. Well, that's because VOR radials are magnetic. VOR radials are magnetic, and this longitude line is true north, and we'll talk more about that in class as well. This down here is the closest flight service station. So in this case, the closest flight service station is Albuquerque. So just know that when you're trying to get a hold of flight service to open a flight plan or close a flight plan, or you want some weather information or whatever, you're trying to reach Albuquerque flight service. And sometimes you'll see frequencies up here, and different ones mean different things. In this case, this is the flight service frequency, and they're receiving on 22.1, and you're listening to them on the VOR on 17.8. So what you're going to do is you're going to, on COM 1 or COM 2, dial in 122.1, and key your mic and talk to them and say, Albuquerque flight service, this is Cessna 123 Alpha Bravo. I am 50 miles outside of Albuquerque requesting weather information for this airport, or requesting to close my flight plan, or whatever it is. And then you're listening, though, on that nav 1 or nav 2 to that 17.8 frequency, where you would listen to the Morse code. You're actually waiting for them to reply, and you'll hear the Morse code, and then suddenly you'll hear them start talking to you through the VOR. It's actually, first time you do it and it works, you're like, wow, this really works. And of course it works. It's just radio frequencies. But yeah, it's pretty cool how that works. So that's what you'll see frequencies sometimes around the box. Refer to your key on your sectional chart for more information. Let's see if it's on this one here. Let's see. I'm not seeing on this one here, but yeah, it's somewhere on this legend here usually. Yep, it's right down here actually. It's right down there. They talk about the different frequencies on there, so refer to that for more information. All right, then we're going to service volumes. So just so you know, not all VORs can go the same distance or whatever. And there's three kinds of VORs we talk about with VFR flying. And this is what we call service volumes, meaning how far out can I reach them and how high they go and stuff. One is called a terminal VOR. It only goes out 25 nautical miles, and it goes up to about 12,000 feet. These are used usually for approaches in and out of airports. Provo for a long time had a terminal VOR. They may still have one, I don't know. But they did have one for a while, but it's a terminal VOR. And then we have what's called a VOR-L or a VOR low. And the upper limit goes out to 70 nautical miles, and the lower limit's 40 nautical miles. And it goes up to about 18,000 feet. And then we have our VOR highs. These are what we use for like up in Class A airspace and for longer distance. It's a HVOR, and it's 100 nautical miles at the very top, between 45,000 and 65,000. Between 18 and 45,000, most of Class A airspace is about 130 nautical miles. Then 14.5 to 18,000 is 100 nautical miles. And this one down here is 70 nautical miles from 5,000 to 14.5, and then 1,000 to 5,000 is about 40 nautical miles. But those are our VOR highs. Those are just things you kind of need to memorize for like the maximum volume or whatever is 130 miles for a high and 25 for a terminal, etc. Alrighty, then we have this chart supplement here. We can figure out, like, this is a VOR-TAC, VOR TACAN. There's different kinds of VORs, but it's a high VOR, and it's on 14.1. And there's the longitude and latitude if you're looking for it on the chart there. So you can find VOR information in the chart supplement. There's different kinds. We have the VOR, the regular VOR. A VOR-TAC is a TACAN and a VOR together. A TACAN is used by military aircraft. It's got DME information as well as that. DME is distance measuring equipment. We don't talk a ton about that in this lesson, but they are kind of part of VORs as well. And then this one's just a straight up VOR DME, which means military may or may not be using these. I don't really know, but they definitely have a DME. DME stands for distance measuring equipment. It's a different box inside your airplane that can help you figure out your slant range distance from where you are to a VOR. We can talk more about that in class as well. All right, let's talk about Victor Airways a little bit. Victor Airways are like highways in the sky, and they're a bunch of low altitude airways that we use, and they're kind of these blue lines you see on these maps that have radial numbers, and they have a number. Like this one maybe hard to see on your screen, but it's Victor 530, and that's Victor 530. This one's Victor 278. Just so you know, this little number below it, that's the distance to the next VOR, the next major waypoint. So this is 127 miles, this is 58 miles, etc. So that helps you with distance as well. Victor 62, etc. But they're just like highways in the sky. They're just defined routes. You do not have to use them. VFR pilots do not have to use them, but they can help you with route planning. They can help you filing your flight plans more quickly and all that stuff. They're just a standardized route system for aircraft, but like I said, you're not required to use them. Just so you know, when it comes to airspace, like, well, what kind of clouds and stuff can I be around? It is Class E airspace, and technically the Victor Airway starts at 1,200 feet AGL up to, but not including 18,000 feet MSL. So AGL on the bottom end, MSL on the top end. Just so you know how wide a Victor Airway technically is, it's 4 miles either side of centerline. And if they're greater than 102 miles apart, then it goes to 4.5 degrees either side. So then you have to look at your little VOR gauge with the 2-degree dots on it and stuff. We can talk more about that in class too if you're confused. We can't have intersections. So in this case, this is a blue radial and this is a blue radial. And you'll see like a little arrow symbol like that, and you'll see a 5-letter name next to it. This is Deborah. And that's the intersection. So you could file this VOR, let's say it's VOR is ABC. You could say ABC to Deborah to XYZ, whatever VOR is down here as well. That's what it looks like on the map there. There is something called reverse sensing. So if you set up a VOR backwards, meaning you meant to put in a to radial, but you put in a from, the needle will go the wrong way. And what I mean by that is this. So you've got the needle kind of hanging down, right? And then you think, and it's off to this side. So you think, oh, the course is off to that side, but you've got it set up backwards. So you start flying that way, and it just keeps getting further and further and further out. And you're like, what's going on? Well, you probably have it set up backwards, and you're getting what's called reverse sensing, because it doesn't know which direction you're facing. It just knows that you selected this radial and is telling you where its relevance is to you, Periodically, you should test out your VOR, make sure it's working properly. There's a couple of different ways to do this. One way is something called a VOT. There's not VOTs everywhere, but if it's in the chart supplement that there's a VOT at an airport, you can go check it out. So you basically are sitting at the airport and you turn to the frequency, and you should be able to dial in 0 degrees or 180, and it should show if it's 0 degrees, no matter which way you're facing, because it's a VOT, it's not a VOR. It only transmits that 0 from and 182 radials, no matter where you are. It's not meant for navigation at all. But basically, you just tune in the VOT, you dial, put it at 0, and then you read how far the deflection is off, okay? It can't be more than 4 degrees off. If it is more than 4 degrees off, so you've got it set to 0, and it's showing you that you're 6 degrees off course, quote unquote, you shouldn't use that VOR. It's got an accuracy of plus or minus 4 degrees for ground checks. Now, there are ways to check it in the air. If you know where 2 cross radials are over a mountaintop and you're over that mountain and you're flying, you can cross radial those and see how far off they are. And if they're more than 6 degrees off, you shouldn't use it in the air. We'll talk more about those in class as well. But if they're within those tolerances, it's perfectly fine to use it. Now, there's a way to determine your position using VORs. You could use 2 different radials. We'll talk about that in class. A to and from indicator. We'll talk about that in a minute, how it must match the aircraft flight path. And you could, if you set it up backwards, you could have the wrong position, so you want to make sure you set it up correctly so you don't get reverse sensing. And CDI deflection indicates course correction direction. And we'll talk about that as well. Basically, that's really honestly in a nutshell how to use VORs on this one slide. But what you can do, if you have a VOR here and you have a VOR down here, you could dial in a radial from that and center we call it homing. You could home that VOR and center up the needle and then center up this needle. And where they cross, well, that's where you are, because you're on that line and they project out and they intersect, and that's where you are. And we'll talk about these other things about how the CDI determines which side it is. We actually talk about that quite a bit in class. All right, we're talking about GPS a little bit. There's going to be some stuff you're going to need to read on GPS in your book. Currently, this year, we're using this book right here. So I actually have it in the study section on Canvas of what you're supposed to study. I say, hey, make sure you read these 2 pages, because there's a lot to GPS that we don't talk about in these slides. After I made the slides and made the notes and everything, I was like, man, I should have probably added a bit more. I'm going to talk about it in class. So, but definitely, if you're not able to make it a class and you're watching this video to supplement class, you want to read that stuff that's on Canvas. It's in the study section. Right before it tells you what pages to study for the test, it says, hey, make sure you read this section so you know this stuff. But we're going to definitely talk about it in class. But GPS, or a global positioning system, basically it's a network of satellites, and you have to have more than 4 satellites for it to work properly. It can provide longitude, latitude. It can provide some altitude information, and definitely provides time. We integrate it with pilotage, dead reckoning, and VOR usage. Now, we haven't talked about pilotage and dead reckoning yet, but you should know that it's used a lot for situational awareness and VFR flying. Most pilots just solely rely on GPS. If their GPS goes out, they're almost like dead in the water if they're in an unfamiliar area. So hopefully you're a little bit more resourceful than those pilots, but it's really super, super handy to use. It's got a huge amount of advantages, and it's very easy to use in the airplane. Now, there's this thing called RAIM. And RAIM is required for GPS reliability. And I believe RAIM stands for Receiver Autonomous Integrity Monitoring. And you need more than 5 satellites for that to be checked. And I'll explain that in a second. So yeah, let me explain it now, I guess. So what RAIM does is you can put in like, hey, I'm flying from this airport to that airport. And you can put that in on the ground before you take off. Or in flight, you can do it too, but I try to do this as part of my pre-takeoff check if I'm going to be using a lot of GPS. So I'm going from one airport to another, and I say, okay, I'm leaving this airport, and here's my destination. And it can calculate really quickly, say, okay, it's going to take you about 45 minutes to get there. It's going to take you 3 hours to get there. And then what it does is it looks at the satellite configuration that's going to be there. Let's say it's going to take you an hour to get from one place to another. It can look at the configuration of the satellites and say, okay, you're going to have enough satellites to have integrity with your GPS. Or it's going to look at it and be like, the way the constellation of satellites is working right now, you're not going to have enough satellites to have. So it'll say RAIM failed, or it'll say RAIM checked, or RAIM okay or good. If it says RAIM okay good, that means, hey, you're going to have the right amount of satellites when you get there for it to work. Doesn't guarantee it's going to work perfectly, but it's saying, hey, based on what I can calculate with the satellite constellation, you should be in good shape. So that's something that you should check before every takeoff is your RAIM. And if you're flying IFR, using it is, I think, required for you to check it before you take off. If it's one of your primary sources of navigation, or you're going to be shooting an approach in bad weather using GPS, you have to check RAIM, because if it's not good, it could lead you really astray, and that could be really catastrophic. And this takes us out of VORs and fancy GPS systems and into kind of the old school way of navigating, and this is pilotage and dead reckoning. And so let's talk about the differences here. So pilotage is navigation by landmarks and checkpoints. Literally, it's like look out the window, see landmarks, and then check with a map. Oh, I see a lake over there. Oh, I see a mountain over there. There's a mountain and a lake. I'm between them. Okay, I must be here on the map. That's what pilotage is. But then dead reckoning is kind of the other way around. That's like calculating stuff on the chart and then checking it with landmarks as you fly along. And it's based on time, speed, distance, direction. You use a plotter, you use the E6B, you use lots of different stuff for that. We honestly, as pilots, if we're using one, we're probably using both at the same time. And if you don't have GPS or VORs, your plane's not capable of it, or you're in an area where they don't have that, being able to navigate with pilotage and dead reckoning is pretty essential. So we're going to talk about dead reckoning and nav logs. This is going to be kind of an introduction to this. And in class, we're going to plan a trip where we're flying between two different things. And we're going to be filling in this this kind of nav log here. Let me get a picture of it here from your test. From your notes. And basically, yeah, you're going to have this little nav log. We're going to fill this in. We're going to do some basics calculations. In a later lesson, we're going to fill in an actual nav log. It's got a lot more detail to it. But this is a good introduction to how all that works. So there's not a lot of notes to take here. It's mostly just kind of us going through some different stuff here. And we talk about different kinds of airspeed in class. That's kind of a review from an earlier lesson. We use the E6B. We use charts like winds aloft charts, calibrated airspeed, pressure altitude charts. We're using all kinds of different stuff. And then we're going to get to diversions. So jump to your notes about diversions, and we'll do all that other stuff in class. Because sometimes things do not go as planned, and that's when diversions come in handy. So I teach the ABCs of diversions, So basically, A is the airport. Let me back up a second here. You're flying along in your airplane, okay, and something doesn't quite look right. Let's say you're flying along and you get told you got flight following, and ATC comes along and says, hey, your destination is, Show Low, Arizona, correct? And you're like, yep, that's me. I'm going to Show Low. And they're like, hey, just so you know, there's an airplane disabled there on the runway, and they've closed the airport. And you're like, oh, no. I got to make a choice. Do I turn around and go back? Do I go to a different airport? Do I go to Show Low and circle, and hopefully it opens? You got to make some choices. But if you decide to go to a different airport, that's called a diversion. And so the first thing you should do is choose a suitable airport. It should have the right runway length. It should have the right services. Let's say you have an alternator failure and you have to divert. Well, you should probably go to a place that has maintenance if you can, if it's in the daytime. If it's an emergency, then yeah, you go get your wheels on the ground, be safe. But honestly, if you can find a place that it's what we call suitable for the situation, then you should choose that first. And you want to check the weather. You want to get as much information as you can. It might be a good time to call flight service and ask them some information. You want to make sure the runway links work. You want to calculate your landing distance and all that good stuff. That's airport, A. B is best heading. Basically give a rough heading, say, okay, looks like pulled out my chart, drew a line. Looks like it's roughly a heading of 265. I'm going to turn to 265 right now. Now, if you have a GPS in the plane, you can just dial that in and turn to that heading. But you don't want to be going in the wrong direction. You want to turn and head in the right direction so that you can make sure that you don't burn a bunch of fuel going to somewhere you're not going to now. And take into account that. But the most important thing is turn to that heading once you've figured it out. Turn to that heading. Just stop wasting time and turn to that heading. And then note the time of the diversion so that you know how long you're off course now. Because in case you got to backtrack to your course or you want to know your fuel burn, things like that. So note the clock. A, B, C, airport, best heading, clock. Then we have D, distance. How far is it to there? Now I'm going to start doing some real calculations because I'm really planning on going there. Okay. Oh, it's 180 miles. Okay, cool. I'm going 120. I'll be there in about an hour and a half. And that's what I'm going to figure out next is my estimated time and route. Now, I could do it in my head, or I could pull out my E6B, which is a way more accurate, and do it with exercises we learned in class. Now that I know how long it's going to take me, I can figure out my fuel. So I can determine how much fuel it's going to take me to get there. Okay? Sometimes these diversions could be hours away to a suitable airport. When you're at the airlines and divert, you're always thinking about, well, do I have a crew there on the ground that can help me offload these passengers? If it's an international flight, do they have customs, things like that? Then we have G. I always say geography. What kind of terrain is between me and there? Is it a major city that I'll be flying over? Maybe I should change my altitude so I have more gliding distance. If it's over water, is it through unfamiliar mountains? Things like that. Am I going to be able to get over those mountains? Look for that. And then, because then I'm going to talk about hazards. Any threats to safety. How tired am I? What's the weather like? It's been turbulent the last hour. I'm really unfamiliar with this airport. I better brief it. It's right in the middle of the city. I don't know, it might be busy. So this is when you're going to talk about hazards, and you're going to talk about them out loud. And you're really going to do that good threat assessment, that PAVE assessment. You're going to talk about what hazards do I have as a pilot? What hazards do I have as an aircraft? Is my aircraft capable? Am I capable of flying this airplane? What's the environmental hazards and what external pressures I have? Some things you want to consider when you divert is not every airport's a suitable divert, meaning, that airport is class B and I don't have a transponder or whatever it is. You want to make sure it's suitable. It has to be reachable and that you have the required fuel to get there. Make sure your airport solves more problems than it creates. Be like, yeah, I can get on the ground real quick, but now I'm stranded in the middle of nowhere in Arizona and I can't, get back in the air or anything like that. And you want to make sure you always double check your math. You want to make sure that you didn't mess up. You're not going to run out of fuel, things like that. And then we watch a video on it. And that is it. See you in class.